Hi, class. With the switch to online, for some of you and for those that have been online, I'm going to be creating some instructional videos for the elementary statistics course. And the first thing, just the schedule. The schedule really is going to change, and I want to bring that in here. And on the syllabus, this is the online syllabus addendum. But basically the same thing. Of course, the attendance policy is not going to be in play for the on-site course, but so when we get on here, we've gotten through all this material already, and we had the Unit 3 exam, and everybody should have their results from that. And then we're really working towards our next exam. So exam 4, which will be here in this week. Again, same kind of format as before. It'll be online, and I'll put it up on Canvas, and you'll have to complete the exam and load it into the Canvas grading area. So everything went pretty well for the most part for the Unit 3 exam, and I think that that'll work out pretty well for the next part also. So moving forward again this week, the 23rd through the 27th, we'll be working on hypothesis testing, and that's with the claims about means and proportions, and not necessarily in that order, but these are one sample means and one sample proportions. And then you'll see next week it talks about two sample mean testing and two proportions. And that's really will be the bulk of it. So Unit 4 is going to be really all on hypothesis testing, which is just another application of that normal distribution. So we take all the ideas from the normal distribution that we learned about, finding probabilities, finding confidence intervals, and then kind of just changing that a little bit and giving us another option on how we can use the normal probability distribution to help us support ideas and test claims and so on. And I'll talk more as we go through these examples. But then again, so if you're looking forward, our next exam will be online, and it will be in April, this week of the 6th through the 10th. So I'm going to move this off. And remember, this video, this is the first new one for this semester, and we'll just be trying some things. So this is kind of be a little bit of an experiment, and the videos may be a little rough and seem a little unorganized initially till I figure out how I want to do these. But I'm using the Microsoft Whiteboard and just going to write on that and talk and bring in the calculator, and hopefully it'll be enough of instruction. And if you have questions, as always, you can email me, and I can try to maybe incorporate those answers into a video when we review for the exam. So let's go ahead and get started. And hypothesis testing, again, is a common term. It's been around for a while. And what we're really referring to is statistical hypothesis testing. And so statistical hypothesis testing, that's really, we're testing a numeric claim about some population parameter. So for example, let's take a look at the idea here. Let's say that a car company is claiming that their vehicle gets on average 28 miles to the gallon. Okay. So again, the claim, that's going to be a population claim. So we're saying that all of the vehicles on average get 28 miles to the gallon. And let me see, again, I have a new board here I'm working with too, so I've got to try to figure out how this thing works. So the mean, and again, a population mean equal to 28. Okay. And so we want to test that, and why we'll talk more about later. It could be that there may be some complaints from people buying that vehicle. They're driving it around and they're checking their gas mileage, and maybe they're getting 24 miles to the gallon on the highway, and so this is supposed to be 28 miles per gallon highway. So what we would do is we would maybe just get some vehicles and drive them around and see what we come up with. And I want to compare this to what we had been doing before. Now, I'm just going to come back and talk more about this in a little bit. Now, let's say that we go out and we say we're going to pick 40. So I'm going to have n equal to 40 cars, and we're going to drive those around and see what kind of gas mileage we get. And some will get, maybe 30 on the highway, some will get 22, some will get 27. So again, remember, there's a variability involved in gas mileage when people drive vehicles. So we know we're going to have a sample mean, and we're going to say that from our data collection, that comes out to be 26.7. Okay, so it's our sample mean, and our sample standard deviation is 4.2. Okay, this is our sample data. These are our sample statistics. Okay, so remember, statistics, numbers describe our samples. So these we refer to as statistics. And really rough idea, we could just say, there's our results, and we don't need to do any fancy stats or anything. We could just say, well, it looks like 26.7. That's lower than 28. Then we're going to say this is wrong. Okay, now, and some people might say, well, wait a minute, that's close enough. I think the 26.7 is close enough to 28. We know there's going to be variability. Let's let it okay. But we would probably get people arguing maybe one way or the other. And so we need a standard. And I talked about the empirical rule where everybody just kind of said, hey, that empirical rule when using the normal distribution, we kind of said the plus or minus 2 standard deviations was going to be our standard guideline for things as being normal or maybe not so normal. And we need that in hypothesis testing too, because we might have a lot of different opinions on these results, whether this sample data supported that original claim from the car company on the highway gas mileage. So that's kind of what a lot of this is going to be. We're talking about what is that standard, how does it set up, and what is the standard process when conducting hypothesis testing in any research that's involved? So what we're going to do is be talking about the standard, okay, in statistics that everybody follows. And it's going to involve some terminology and some different ideas. And it'll be a little confusing maybe at first, but eventually, once we do enough of problems, I think it will kind of come together. So just remember, the idea is simple. What we're doing here is we're comparing this 26.7 to this 28, and we're saying, is that 26.7 close enough to 28 to agree with this statement right here, this statistical hypothesis, okay? Again, remember mean, that's a population parameter, that's a numerical value. So we're going to see how this goes. So we're going to be doing what we call one sample mean test, hypothesis test. And we'll talk about this compare it to the confidence intervals that we had talked about before. So again, what we are still using is the normal distribution. So I'm going to try to draw a curve here. Well, not so great. I'll get better at that set. Now, what we're going to do is put in the middle 28. So we're going to take a conservative approach. Hypothesis testing is a conservative approach where it says that we're going to assume up front, for at least now, for this to be true. We're going to assume it's true. And then we're going to say, how likely is it that if this 28 were true, that this would have occurred? Because did we expect to take these 40 vehicles or drive them all around and come out exactly on average to 28, right? Theoretically, yeah, that's what we expected, theoretically speaking, but realistically, we only have 40 cars. You know, if we had a sample size of 100,000, maybe we would end up right at 28, but we don't. Remember, we work with samples, reasonable samples. We got all those issues we talked about. Why do we sample? Well, because we have to, basically. And so we know we're going to be off a little bit, always. So this number of being off or less than 26, that's not really that big of a deal right now. We expected it would be off. So the thing is that is it way off? Is it far enough away that we could maybe question this original claim up here? Okay, so what I want to do then is very kind of a simple idea. This is just exactly what we were doing before, is that we want to find out how much area is under the curve beyond the value that we came up with. So here's our sample mean, right? So this is our X bar. So we take our sample, put it on our curve, and we're going to find out how much area there is to the left of that. Now, how are we going to do that? Well, we've already done that a lot, right? Remember, area under curve, we used what? Before we used to use normal CDF. So remember, we would do something like this. We would do normal CDF, and then we would have to do negative E99, comma, right? That's our boundary out here. We call this point E90, negative E99, up to 26.7. So we were defining this shaded region under the curve, and that's going to give us our probability, right? So 26.7, and then the mean, our hypothesized value, right? 28, and our standard deviation. We're going to have to use the 4.2 divided by the square root of a little triangle there. Not sure why. Divided by the square root. I think it snapped a grid. That's why. I gotta turn that off. Divided by the square root of 40. That's our estimate of the population standard deviation, standard error of the mean. That's all we got. So again, we're going to bring our calculator over. and do. Remember when we found that, we went into stat, test, and this time we're going to run a t-test. Okay, t-test. All right. Input is stats. Hypothesized mean. See this mu sub 0. Whoops. Get out of there. Enter. All right. All right. Hypothesized mean or claim. Sometimes we'll call it the claim. 28. Sample mean was 26.7. And our standard deviation was 4.2. N is 40. Okay. And I'm going to go down to here. And I'll explain it a little bit on this. Why I'm clicking that. Calculate. Now, we're going to remember these numbers, and we're going to come back to this. And I said these videos, I'm a little bit just getting used to this, so it is a little bit of a difference. Whoops. So yeah, let's go back. Stat, test, t-test. I gotta get out and oops. There we go. Okay, so we have this t negative 1.57. P is 0.028. There's our mean and standard deviation and sample size data that we put into this. All right, now this T and P. Let's talk about that a little bit. Well, if I can get this moved, here we go. All right, off the way. Now, this number right here, okay, this value, normal CDF, negative E99, we had to do all this. This was our standard error. That'll give us this area under the curve, okay? Now, what we just did in the calculator, I didn't use normal CDF. So the big difference between what we did before and what we're doing now, as you noticed, I went to stat and test, and I ran a t-test instead of the normal CDF. Well, it's basically the same thing, but it gives you a little bit of a difference. So it is a slight change. So this area, we're going to come up with basically the exact same thing in a different way. So this that we did before, you'll notice we're not going to be using this anymore, okay? We don't have to worry about dividing by the square root of 40. We're still using a sampling distribution. This is a sampling distribution of the means, okay? We're still using this idea of going to the left or going to the right or so on. And we're still plugging in the mean and standard error, and we have a hypothesized value and so on. Okay, so all right, so let's go back to our output and see what we come up with. So the P or our P value is that area under the curve 0.0287. Okay, 0.0287. So that's here. That's the amount of area under the curve. And that's same thing we would have gotten here. All right. But we're going to, let's see if I can. Oops. Okay, again, I'm still trying to get used to this. There we go. Here we go. All right, so I'm going to take this off. So we see that we're doing the same thing, okay? All right, back to the, and I'll have to try to figure out how to get rid of that. Let's see. I'll have to, all right, let's go ahead. So I'm going back to now, instead of that, I'm going to put down here, we have this, and we have t now, negative 1.958. And we'll put that, we got p equal to 0.028. So, all right, and we had n equal to 40 up here. All right, so this is really what we're going to be concerned about with our outputs now, because this is going to help us make a decision. In hypothesis testing, the idea here is that we're going to set up what we refer to as a null hypothesis. So this right now, I'm just in kind of general, not being too technical, and add a lot of terms in right now, and we will as we go. But so right now, what I'm saying is, can we support this? Right? Can we support this? Well, it depends. It depends on how far our sample mean, which is a 26.7, is away from the 28, or that hypothesized population mean. Now, the only way we can kind of tell that in terms of statistics, because we can tell right away. I mean, you can say, hey, it's 1.3 miles per gallon different. Okay, well, I mean, that's what it is, right? And some people might say that's okay, it's not okay. So we're not getting into that argument. We're getting into the argument of statistics, and we're still using that idea of plus or minus 2 standard deviations. So roughly, very roughly, is this more than 2 standard deviations away from the mean or the middle? That's kind of what we're asking. Now, we're running a t-test, so this normally we would have the z-table. We would be able to look up and do that in terms of 1.96, and you'll notice that actually is very close to 1.96. But we're running a t-test basically because it adjusts for sample bias. So the z-distribution idea is still there, with the t is just a slight adjustment for sample size bias. So we have 40. We know that's kind of small, so we're using this, and we've always used the t-distribution in our course. So how do I know if this is basically more than 2 standard deviations away from the middle? Statistically speaking, well, that's why we have the p-value up there. Because we look at it then in terms of area, because the more you move away from the middle, the smaller the area is. So if the area here is very small, then we know that we're pretty far away from the middle. So we're comparing things in terms of this area, or what we're calling now the p-value. So the p-value is a new term that relates to area under the curve, right? Area under curve beyond some given value, in this case, our sample mean. Okay. So basic idea that we're gonna have to I'll keep reminding you of again. Here's a general rule. Okay. If P is less than alpha, then reject H sub 0. All right, what does that mean? Well, if P is less than alpha, so let's say P is what, 0.0287. If P is less than, so P, if that is less than, and I'm going to put in 0.05. Okay, why? Where did I get 0.05? Well, 0.05 is the standard. I got that from basically the Z table. Okay, again, so the idea of how much area was there beyond 2 standard deviations underneath the normal curve based, with regards to the empirical rule. Well, 5%, right? We had 95% within 2. So that's kind of the idea here, right? So if, again, we're saying basically the same thing. So this is less than this, that means then we're going to reject, right? P is less than alpha. We're going to reject H sub 0. In our case right up there, H sub 0 is simply that the mean is equal to 28 miles to the gallon, okay? So from our data collection, we're going to just wrap this up. We'll do another problem. We'll keep adding some things in. And then again, I'll keep working on this and get used to this, and videos will kind of be a little more efficient. All right, so let's get back up to here. So again, we claimed that our cars were getting 28 miles per gallon on the highway. We got 40 of them, had people drive them around, and we collected the data. So on average, they got 26.7. That whole group of 40 on average came up. Some people got 22, some people got 29, some people got 21, whatever. And here was our variability for that set of data. So this is one sample of data that we're working with. We plugged the numbers in to the calculator, right? We ran a t-test. We ran a t-test. One sample mean, t-test. On your calculator, it's number 2 under t-test. So we got these values out of the calculator, these two, right? And then we decided, as soon as we got these calculators, we could decide. All right. So since this p-value was very small, smaller it is, that means the further it is away from the middle. You're whatever you're testing here, right? It's going to be further away from this. So this is pretty small, 0.0287. Then we reject it. So the 0.0 is less than 5%, then reject mean less than 28, right? Okay, so we are going to figure out how to clear this thing. And again, I didn't talk about types of tests. We're just going to do 2 problems on this video. And I'm going to keep working and we'll get some more up there. Let me just see. Settings, clear canvas. Great. Okay, So we're going to do another problem. As soon as I get that. And this one will hopefully this will go a little smoother. We'll add some things in as we go. Now, all right, this is a test again. This is a hypothesis test. And it's a statistical hypothesis test. So we need some kind of claim, some numeric claim about a population parameter. And this is an article that I found in a Consumer Report magazine. They did a test on these devices that magnify sounds. It's called Wild Planet Toy Supersonic Ear. It was sold as a toy one year at Christmas for kids, so that they could put these headphones on and point this satellite-looking device handheld, and it would like magnify, so you could hear sounds like in another room or way far away, and so on and so. So they tested it, and basically anything over 120, they said. So 120 is kind of our max, and again, but so on average, we don't want this thing to be over 120, all right? So we're just going to test again. I'm going to put up here that the mean is equal to 120. Okay, and this is decibels, 120 decibels. So this is our kind of starting point. And then what I want to do is talk a little bit more about setting this up initially. So I want to draw a curve. I'm going to start there all the time. And I need to turn off something. Object snapping, there we go. Turn that off. Okay. So this device, I'm going to start again and click canvas. And all right. So the mean equal to 120. And again, this is what they have written, so this is what I'm going to use. Don't know that I would use that in this case myself, but that's good. So all right, so no snap to grid. Is it object snapping, ink to shape? Oh, there it is. Ink to shape. I'm getting good at clearing the canvas. Mean equal to 120. So there's a claim, a numeric claim about a population parameter, right? So we're saying that on average, the loudest sounds that the supersonic ears on average are producing are 120 decibels. And try once again, draw my normal distribution. So we're assuming we're using the central limit theorem idea that we can use the normal distribution to approximate probabilities. Okay, so we're going to put that 120 in the middle. That's our conservative estimate, because we want to say, listen, I agree with what they're saying. That's how we're starting out. It's like in a court case. I like the example of the courts where you say a person is innocent until you can prove guilty. So that seems very appropriate. We're using the kind of thinking or conservative estimate that we need a lot of proof. If you want to send somebody to jail, you just can't have a little bit of proof. We'd have 100 times more people in jail than we have now. We've got to have a lot of proof to reject this 120, not just a little bit. So we can't end up having a mean of 121 and saying, oh, um, that's higher than 120. So let's say that they're definitely bad. It's going to pull these off the market. So 120 decibels on these supersonic ears, and we're going to test that. Now, I want to add in a little bit here. When you start your problem, you've got to think about why you're doing this, right? So, are we just trying to test if the supersonic ears are, on average, their loudest sounds are greater than? Is that a bad thing? Well, yeah. If kids are putting these on their heads and listening, and the sounds are getting way up here on average, then that's going to damage your ears. Okay, so I have a critical region up here that I'm concerned about. Okay. All right, so I have a concern about. Now let's look at the other side of this. Of course, if it's right in the middle, it's right exactly where I said it is, and that solves our problem. But over here, if the sounds are the maximum sounds that it produces, if they are over here under 120, do we really care about that? Well, not in this case, because this consumer report looked at these because there were complaints that they were maybe hurting the kids' ears. They're so loud. So here, we don't even care. There's no critical region over here. If we end up at 119 or 118, great, great, we're happy. All right, so what we need to find now is simply what's the area under the curve. Oops, over there. And if we end up here, so we're kind of assuming if they value up here, we're going to want to reject. This is our region of rejection. So I've got to come up with a null hypothesis because everybody needs to know up front, what exactly am I testing? Am I testing around 120? Well, no. My H sub 0 mean less than or equal to 120. Okay, now I know you're saying, wait a minute, you just said greater than. Oh, well, again, this is the hardest thing for people to get used to in hypothesis testing. Remember, if I take somebody to court, I think they're guilty, but I start out by saying that they're innocent. I say the exact opposite. We bring them in and say, hey, this guy's innocent. And then we try to come up with proof. Then we collect our sample. So this is innocent, right? We're saying that, hey, they're innocent, right? These things are good. There's nothing wrong with these supersonic ears. That means the decibels would be less than or equal to 120. So it'd be all down here. That would be that this is okay, right? Innocent, nothing wrong. This is the critical region up here. It's above 120, right? They're too loud. All right, so once we get that set up, we get this set up, the rest is actually really easy. We just simply put in the sample data. So we have a sample mean. In this case, that'll be given 124. And a sample standard deviation of 11.8. Alpha equal to, and now we have a sample size. Remember, because this is a sampling distribution, so we're testing about the whole group average. This is 25. It's 25. So remember that. All right, this is sample data here. All right, sample statistics. Sample stats. And this is our claim up here. So we got 124. So here, so again, let's take a look at this. 124. Man, that's high, right? I'd like to reject that. That's way too high. Well, it's not up to me for my own opinion, right? We can see right away 124 seems too high, but statistically speaking, is that high? Okay, is that far away? And remember, we can kind of judge that by looking at our p-value. If the p-value is really small, then we know this number is statistically far away in terms of standard errors. So that's what we need. We need to know basically, is it more than 2 standard errors away from the middle? Basically, I'm going to, again, but let's take a look at calculator. Okay, let's bring this over and get our p-value and clear. All right, so we're going to go into stat test number 2, right? T-test. I'm going to run one sample mean t-test. We have one sample, and we're using the normal distribution. We're using the t-distribution basically, which looks almost exactly the same. And I'm going to hit enter, inputting stats, and I need to put in here 124 is our wait, our hypothesized mean is 120. There we go. And the sample mean is 124. And let's see, 124. Okay, it's kind of slow. Standard deviation, 11.8. A lot of variability in those sounds, which is what we kind of would expect. All right. The sample size is 25. And which tail test? Well, we are pointing to the right. Our critical region is pointing to the right. Calculate. There we go. So let's see what we got. And see. Okay. So we ran the t-test. Again, we put in 123. So I do have, I was going to say, I have to click this very slowly. I got to remember to click this slower or I get the wrong number. Okay, so the t-test, 120 is our claim, 124, 11.825, right? Okay. I think we got it this time. Much better. Okay. All right, let's put this up here. We have t equal to 1 point, and we're just going to go 1.69. P equal to 0.0515. And again, this is our calculator information here. And now we just need to conclude. All right, now again, I didn't write an alpha up there. I'm going to put it up here now. I'm going to put alpha equal to 0.05. Again, that's the standard. That deals with that whole idea of plus or minus 2 standard errors. And we're going to leave it at that. So if P is less than alpha, then reject, or no, hypothesis. So let's look at P. P is 0.05. It's pretty small. Is greater than 0.05. Do not reject our claim up here, right? We're not going to reject that. Null hypothesis right there. So this is slightly larger than this. Even though you're saying, hey, that's so close, we should be rejecting anyways. Well, yeah, you're probably right, but that's not how we do this. Everybody, follows the standards. We'll talk about maybe changing this, but this is it. P-value greater than alpha. Do not reject. H sub 0. Okay, we're going to stop there and then just keep looking, and I'll do some more problems for Thursday. I need to find my